Recording in 3, 2, 1. All right, and welcome to Advanced Algebra with Financial Applications. We're starting a new unit. We're saying goodbye to consumer credit, goodbye to credit cards, and hello to automotive ownership. The links are in the chat. Let me share. Let me share my screen. Right. All right. I was trying to extend my lesson planning a little bit, and I overplanned. So what I thought was going to be just 1 day looks like it's going to be 2 days of instruction. All right. So this is what it should look like when you open this up. All right. Unit 3, automobile ownership, lesson 1, buying or selling a car, day 1. And because we have a new lesson and we have a new learning target, and that learning target has a lot of pieces to it, which you're going to learn over over 2 days. So this is learning target. I can compute the mean, the median, the mode, the range, quartiles, and interquartile range. All right, you can compute these 6 different kinds of what's called descriptive statistics. All right, that's our learning target. You'll get there. Don't worry about it. It's not too bad. The confusing thing about this topic is that the mean, the median, and the mode are all measures of central tendency, and they all unfortunately start with M, and students get these 3 confused all the time. Okay, so we're going to talk about it, and I'm going to repeat myself a whole lot because I want you to know the difference between the mean, the median, and the mode. The mean is the average. The median is the middle, and the mode is the most. The mean is the average, the median is the middle number in the data set, and the mode is the number that shows up the most. So we'll talk about it. What is statistics? Statistics is a branch of mathematics in which data is analyzed and interpreted, right? What is data? Data is stuff that's measurable from the real world. What is the mean? The mean is the average, or the arithmetic average. All right. We're going to be talking a lot in statistics. We're talking about data sets, right? A collection of numbers. And if one of those numbers just doesn't belong with the others, it's like way out there, we call it an outlier. It's way out there, right? An outlier is way out there. It's nowhere near the rest of the numbers. The median is the middle number. If you're familiar with like that little strip of yellow or white dotted lines in the middle of the street that says all the traffic keep to on the right side and all of you keep to the other side, well, that's the median, right? If you cross over that dotted line or that line, you've crossed the median. All right, ascending order. When you group numbers in ascending order, they go from least to greatest. They're ascending. The numbers are getting bigger as you read left to right. If the numbers start at the biggest number and get smaller, that's called descending order. When a data set has an outlier, there is some skew, right? When there are outliers, you have skew. And we'll talk about more about what skew looks like when we graph it. Resistant means it doesn't move easily, right? It doesn't mean it doesn't move at all. It just means it doesn't move very easy. It resists. To resist means to not want to change very much. All right, we're going to talk about how the median is resistant to outliers, while the mean is sensitive to outliers. Okay, the median is resistant, the mean is sensitive. The range, we're going to talk about the range. When you take that biggest number in a data set and the smallest number in a data set, and you find out the difference between those 2 numbers, max minus min, the biggest number minus the smallest number, that gives you an idea of the range. Now the range is very different from mean, median, and mode. The mean, the median, and the mode are all measures of central tendency, right? They give you an idea of where the data is centrally located, while the range gives you an idea of how dispersed the data is, how spread out the data is. The range gives you an idea of how spread out the data is. So this is a different measure, statistical description. All right. We're going to talk about quartiles. I'm not going to talk about them now because you need to see these in context. Otherwise, it'll make no sense. We'll talk about subscripts later, and an interquartile range we'll talk about later. The mode. Okay, the mode is the most, right? If you've got 10 numbers in a data set and 5 of those numbers are 7, well, 7 is showing up so darn much that you might want to pay attention to that. And that's where the mode comes in. And when the same number pops up the most in a data set, that's the mode. And then we have a word called bimodal, which you're probably not familiar with. Bimodal means when we graph these things, it'll have 2 humps. Okay, bimodal, though, that'll have 2 peaks to the graph. All right, put your name where it says your name. It's day 1, so we'll be walking you through all this. I'm going to be asking you those learning targets again, right? Just in case someone asks me, hey, Mr. Solt, how do you know that whether your students are actually paying attention to your learning target? Well, I can say, I make them copy and paste it into this little thing here. So I select that learning target, I Control C, and then I can just Control V here. You could also say, I can compute mean, median, and mode, and that'd be fine too, if you'd rather just type that. You don't need all of that right now, because mean, median is what we're going to primarily be focusing on today. The mean and the median. All right. The next piece. This here is the math topics we'll be talking about. This next 3 things are actually mostly for my planning of instruction, but at least I like to include them so you can see what's going on, what I'm thinking, where we're going. We're on Unit 3, Automotive Ownership. Lesson 1, buying and selling a car. All right, we have a warm-up. You and 2 of your friends took on a job together. You're going to help someone move into a new apartment. All right. You all worked for 2 hours, and the person gave you $500 to split between the 3 of you. If you split the money equally between the 3 of you, how much will each of you receive, rounded to the nearest dollar? All right, let me give you some time to think about that. You can hit me up in the chat if you think you got a response. Take a minute. How are you going to divide 500 into 3 equal pieces? There we go. Now, I would say that there's a rounding error there, right? You have the right idea, but there's just I think you rounded to like the nearest 10 cents. Keyshawn? If you rounded the nearest dollar or rounded the nearest cent. In this case, it says rounded the nearest dollar. There we go. All right. So today we are going to do this a lot. So you have this $500. How do you split it up equally? How do you split up $500 equally among 3 people? Well, we're going to use the division function, right? The operation of division. If I take 500 and if I divide it by 3, what this does is it's going to break 500 into 3 equal pieces, right? 500 broken up into 3 equal pieces is $166 and rounded to the nearest cent, 67 cents. If I was rounding the nearest dollar, I would round this up to $167, just like Keyshawn said. How can I kind of prove to myself that I've done this properly? Well, I can always take $166 and say 67 cents, and I can multiply it by 3, right? What if 3 guys each get paid $166.67? Well, that would be 501 cents, right? So this is kind of that. I can do a little check to confirm whether I've got this right. Why is it 1 cent? Because I rounded up. Had I not rounded up and just kept it to 66.6, for instance, it won't go over. It's now $499.99. All right, next warm up. You took 5 tests. You took 5 tests in this quarter for math class, scoring a 93, an 87, a 95, an 88, and a 100. What is your average test score for this quarter? How can you find your average test score? If you think you got it, you can hit me up in the chat. All right, no one's hit me up in the chat, so let me talk about this. All right, how do I find an average? Well, I think we've talked about it in this class in terms of the average daily balance. Remember, we added up the balance of each day that was owed on the credit card, and we divided by how many days in the billing period. Remember that? We're going to do that kind of situation in this context too. I'm going to add up all the numbers in my data set first. So I take 93, add that to 87, add that to 95, add that to 88, and add that to 100. All right, this gives me a sum. I now have a sum of 463. Now I have to divide this up into equal pieces based on how many numbers there are in my data set. Well, in this case, I've got 1, 2, 3, 4, and 5. 5 numbers in this data set. Therefore, I have to take this 463 and divide it by 5. 463 divided by 5 is 92.6. So that is the average test score of this quarter, right? If you think about the average if the average is a balancing point, if all the numbers were to be equalized into where it was one test score for 5 different tests, that equalized score would be 92.6. All right, that's kind of how to find an average. All right. Well, how can statistics help you negotiate the sale or purchase of a car? Well, if you're planning to buy a used car, how will you even know what a reasonable price is for the car you want to buy? Right? You can find a lot of information about used cars on the internet, of course, and you can also visit a used car dealer. You'll probably spend a little bit more money at the used car dealer. The price for any car depends heavily on the car's condition, whether it looks really great or whether it's rusty or has mechanical problems, and how desirable it is in the marketplace. Some cars are highly desirable and they retain their value fairly well, while as other cars, not so much, right? And they lose a lot of value over time. So you'll probably want to spend a few weeks to shop for a car. Purchasing a car for most people is a pretty big purchase, and you might want to go into that purchase fully informed, which means you probably don't want to just buy the first thing you see on the internet or advertised anywhere. You're going to want to take a couple days at least, if not a couple weeks, to kind of carefully get an idea of exactly what you want and exactly what you should be paying for exactly what you want. You can determine a reasonable price for a particular car by examining the prices of those and similar cars listed in classified ads. Now, an excellent source is the Kelley Blue Book, right? There's a link to that site right there. Also, Edmunds is the same thing. Both of these sites are excellent sources on the internet that you can use to find the value of a used car. And how do they do this? How do they provide this information? They just actually monitor the sale price. Yeah. They monitor the sale price of cars and they just average them together, right? They take, they say, let's take every Toyota RAV4 of this year. Let's find out how much they actually sold for with how many miles and take the average of that and find exactly what this kind of the market value of this kind of vehicle is going for. You're going to want to be smart in your search, right? And if possible, you want to bring a knowledgeable person along with you that knows about cars and mechanical problems and maybe can perhaps help you negotiate for a good price. As you search on the internet, you're going to want to compile a list of advertised prices for the cars you want. Then, once you have data from the real world, you can use statistics to help you analyze that data that you compile. You can use measures of central tendency, which are single numbers designed to represent a typical value for the data. And you'll find that new cars have much less variability, right? You probably don't need to run a whole lot of statistical analysis on new cars because they don't vary much. The data doesn't vary very much because all new cars are basically in the same condition. It's used cars that have this variability in there because it's based on condition of the vehicle. The price you'll pay is based on the sticker price of the car, and different dealers can give different prices, and it's best to compare deals even when buying a new car. So example 1 here. Example 1, used car prices can vary greatly, and a skilled negotiator will have an advantage when buying or selling a used car. So here we go. Jason wants to sell his Ford SUV. Jason compiles these prices from the internet for cars similar to his. He finds one Ford SUV they're asking for $11,000. Another person's selling, asking for $9,900. Another person is selling, asking for $12,100, and so on, right? We've got these values. The question is, what would be a reasonable price for Jason to consider for his SUV? Well, he needs to find, he's got some data here, he needs to do something with this data in order to figure out what would be something in the middle between these values. Jason should probably start with finding the mean or arithmetic average of the 5 prices. The mean is often called the average, and the average is the mean. All right, so when you think mean, think average. When you see average, think mean. All right, these things are the same thing. So how do you find the average? Well, we already talked about it. We're going to add up all of our numbers and then divide by how many numbers we have. In this case, there's 1, 2, 3, 4, 5 numbers. Therefore, I divide by 5. All right, so add them all up, divide by how many there are. In this case, we add them all up and divide by how many there are, and we get 10,500. So the mean of this data set, right, the mean of this data set here is 10,500. It's a number that kind of describes the central tendency of this data. And Jason can adjust this mean price based on the conditions of his car, regardless, and the mileage that has on it and the option it has. If your car has lots of cool options and extras, you might be able to get extra money for it. If your car has extremely low mileage, you might be able to get a little extra for it. If your car has lots and lots of extra mileage on it, more than other cars for its year, then it might be worth a little bit less, right? There's this idea that cars, the engine is only good for so many thousand miles and it needs lots of work. All right, so with that, Carice compiled a list of these car prices: 7,500, 6,500, 5,750, 4,900, 6,250, and 4,200. Find the mean of these prices. You can use this example to help you out. Let me give you a minute to think about this. All right, let's talk about it. If anyone want to hit me up in the chat with what they got? All right, I'm not getting hit up. No one's sending me anything in the chat. Let's talk about, we're finding the mean. The mean is the average. We're going to use the same technique we used right here, right? So I see 7,500. Excellent, sir. That's exactly what I got. 7,500, right? I'm adding this with everything else. So I need a sum, which means I need to add up all my numbers first. All right, I'm adding up all my numbers. Here's my 4,900. Here's my 6,250. Here's my 4,200. I add them all up. I get a sum of 35,100, but I'm not done yet, right? I just found the sum, which is the top part of this problem. I now need to divide by how many numbers do I have? How many numbers do I have? 1, 2, 3, 4, 5. Ooh, 6 this time. I got 6 numbers this time, so I'm dividing by 6. 5,850. All right, that's the mean for the situation with Carice. All right, Nazir compiled a list of car prices. We've got 1, 2, 3, 4, 5, 6 numbers again. Find the mean of these prices. Let me give you a minute. And again, if you want to throw it up in the chat, by all means. Excellent. Well done. Yeah. All right, let's talk about it. Right. First step is to add all the numbers up. First step is to add all the numbers up. I need a sum. I need to add. I'm adding all my numbers up to find a sum. Putting my numbers in. All right, my data is almost in. Last but not least, 5,250. Hopefully I did that right. I got a sum of 44,250. I've got 1, 2, 3, 4, 5, 6 numbers in my data set, so I divide by 6, 7,375. So the problem with Nazir, the average or the mean of these 6 prices is 7,375. All right. So this is kind of an important concept. I'll talk about this more than once. This idea that the mean or the average is sensitive to outliers. Sensitive means the mean is affected a lot by outliers, right? Outliers throw the mean off by a lot. Medians are resistant to outliers. They're much less sensitive to outliers. So let me show you that kind of what's going on here. Dory is looking for a classic 1967 Firebird. Dory finds these prices on the internet. 18,000, whoa, 77,000, 22,000, 21,200, 19,000, 17,500, and 22,500. Dory computes the mean as $28,171.43. Problem is, $28,171 does not seem to be a good representative of this data, right? 28,000 is bigger than all of these numbers except for 77. That's the 77,000, right? This 28,000 seems to be like kind of away from the center of this data. So how can Dory then find, if the mean is not a good representation of this data, how can she find a better representation? Well, kind of the answer here is to go for the median. If there is an outlier, in this case there is, that 77,000, that's what we call an outlier. That 77,000 is nowhere near the rest of our numbers, right? It's just way like, whoa, what's going on with that one? That must be like a Firebird in pristine condition, like all sorts of original parts and everything just perfect. All right, this outlier is a piece of data that's extremely different from the rest of the data. When there are outliers, the mean is often not a good representation. Again, when there are outliers, the mean is not a good representation. In cases like this, you can use the median or the middle score. Remember, the median is like that dotted line in the middle of the road. The median is the middle number to best represent the data. To find a median, you want to arrange the values in ascending order from least to greatest, or descending order from greatest to least. Then you want to pair the numbers starting from the ends of the list as shown and circle the middle number that remains after the numbers are paired. The median is the circled number, 21,200. Notice there are the same number of scores below the median as there are above the median. This is kind of how this works. You put this in ascending order. This 12,000 is actually wrong. I think they meant to say 19,000 for there. But basically what they did is they got rid of the highest and lowest. You get rid of the highest and lowest scores. And after you get rid of your highest and lowest scores, you then get rid of the next highest and lowest scores, right? Get rid of the 18,000, then 22,500. And then you get rid of the next highest and lowest scores, 19,000 and 22,000, until you end up with the middle number. The middle number of this data set is 21,200. So the median here, 21,200. And this price, notice, is a much better representation of the data. When the mean of a data set is not equal to the median, the data is skewed, right? If the mean and the median are the same, then the data is symmetrical. It's not skewed. If the mean and the median are very different, then the data is skewed. The median is much less affected by outliers, right? If that 77,000 had been 977,000, it wouldn't have changed the median, right? Because that 977,000 would have been just eliminated. It would have been kind of crossed off of our list. That's why we say the median is resistant to extreme numbers. All right, I'm going to have you find the mean and the median for the same data set. This data set here is the same as the data set here. So let me give you a minute to find both the mean and the median of these two data sets. All right, let me talk about it. All right, so remember, step one, find the mean. The first step is to add up all my numbers, right? To find the mean, I need to add up all my data and divide by how many values are in the data set. So there's my 1,200. There's my 1,650. There's my 1,500. There's my 2,000. Just adding these numbers up. I want to find the sum of all my numbers. And after I find the sum, I'm going to divide by how many numbers I have in my data set. So first step, find the sum. All right, there I go. I've got 11,200 as the sum of all my numbers. Now I need to divide by how many numbers are in my data set. There are 1, 2, 3, 4, 5, 6, 7 numbers in this data set. So I'm going to divide by 7. And I find a mean of 1,600. A mean of 1,600. All right. The mean has been calculated. Now we have to find the median. Okay. So in my head, I'm going to start eliminating the highest and lowest numbers. Well, my lowest number here is 1,200. I'm going to cross that off and mentally cross that off. All right. Now I see my biggest number here is 2,000. I'm going to mentally cross off that number there. Now what am I left with? I'm left with my next lowest number is 1,400, crossing it off in my head. My next highest number is 1,850, crossing that off in my head. And now I'm left with 1,500, 1,600, and 1,650. Crossing off the 1,500 and the 1,650, I'm left with 1,600 as my median. My median is 1,600 as well. So both the mean and the median in this case are the same, right? The mean is 1,600. Pardon me. The median is 1,600. The next question asks, is the data in this data set skewed? All right, is it, and explain your reasoning. So here's how you can answer this. Well, as we looked up here, as we talked about up here, if the mean and the median are the same, the data is not skewed. But when the mean of the data set is not equal to the median, the data is skewed. So, sorry. Ooh. So we would say, since the mean and median are the same, the data is not skewed. Since the mean and the median are the same, the data is not skewed. All right. The next question asks, is this data skewed? Well, it's the same numbers, only one number has changed, right? We've now replaced the 1,600 with 11,600. Well, let me show you a little trick on the calculator. You don't have to memorize this right now. You don't have to learn this all right away, but this will save you a lot of work in the long run if you can learn how to put data into your statistics, data into your calculator through the stat button. All right, I'm going to press the stat button right here. I have this menu. I get edit, calc, and tests menu, and then in the edit menu, I can do all these things here. Well, I want to edit a list, so I want to press enter right here, and then I have a list of data. I'm going to delete that. So I'm just going to click up. I press clear and I press enter, and then all my data disappears. I want to enter this data here into my calculator. So there is 1,200, press enter. 1,650, press enter. 1,500, press enter. 2,000, press enter. 1,400, enter. 1,850. And 11,600. So Keyshawn asked, I think, how did I find the median before? I eliminated the highest and lowest numbers, right? I got rid of the 2,000 in my head, and then I got rid of the 1,200 in my head. My next highest number was 1,850. I get rid of that in my head. My next lowest number is 1,400. Get rid of that in my head. I'm left with three numbers, 1, 2, 3 that I haven't gotten rid of yet. I'm going to get rid of the highest and lowest of those three numbers. I get rid of the 1,500. Get rid of the 1,650. 1,600 is my middle number. It's the one number left over after I've eliminated all my highest and lowest numbers. That's how I found the median the first time. In this case, I'm going to find the median using the calculator. So I pressed stat. I went in my edit. I put all my numbers in my list 1. Once all my numbers are in list 1, I can press stat once again. I want to go over to the calc menu here Press the right button, move over to calc, and I want one var stat. That's one variable statistics. I'm going to press enter like 3 times. I see that my list is list 1. That's where my data is. 1, 2, 3, and there it is. This symbol right here is called X bar. It stands for average or mean. All right, so this is my mean right here. My new mean is $3,028.57. Wow. And my median is 1,650 now. So my median has only gone up by 50 by changing that one number here. And my new, so I have a new mean of 3,028 and some change. I have a new median of 1,650. So in this case, I would say this data is skewed because the mean and median are not the same. Now, if the mean and the median were fairly close, I mean, like they were only off by a little bit, we might call this roughly symmetrical or not very skewed, right? But right now, in this situation, we have the mean is almost double the median, and so yeah, it's skewed. No denying it. We have an outlier in our data, which is skewing this. This measures the central tendency in this case. Notice the median changed a little bit with this one little change, but the median didn't change a whole lot because remember, the median is resistant to outliers. The median sometimes doesn't change at all when an outlier pops in there, whereas the mean is sensitive to outliers. The mean changed a lot when we change this one number because the mean is sensitive to outliers. All right, we got 15 minutes left. Let's talk about that median. So sometimes you're going to end up with 2 numbers in the middle. If you've got an odd number of values in your data set, like say 5 numbers, well, if you get rid of the highest and the lowest, oh, I don't want to do it that way, do I? Okay, I have 8 numbers here. No, let's do 9 numbers, all right? If I get rid of my highest and lowest, and get rid of my highest and lowest, and get rid of my highest and lowest, and get rid of my highest lowest, I end up with 1 number in the middle. Okay.
Yeah, but those are the 2 most important, like middle tendencies.
Sorry.
So it's like,
I'm laughing because I chose a really bad example of 5 numbers. Can you imagine what would happen if I got rid of all the numbers and you're left with 1 number in the middle?
You guys, I love it. That's hilarious.
That was a completely unintentional, but that's hilarious to me. Okay. So sometimes if you have an even number of numbers, right, you can get rid of the highest and lowest, but you're still left with 2 numbers in the middle. So here's the situation here. We got these 1, 2, 3, 4, 5, 6 numbers. And when you end up with 2 numbers in the middle, you can get rid of the highest and lowest, right? They got rid of the 5,800 and the 9,100. They got rid of their next highest and lowest, which was 6,700, 8,650. They end up with 2 numbers in the middle. When you end up with this situation, here's what you got to do. You got to add the 2 numbers up and divide by 2. You're essentially going to find what's the middle number in between these 2 numbers. So you add these 2 numbers up, divide by 2, voila, you have the median, 7,750. All right, so the median of this one is 7,750. That's what happens when you have an even number of values in your data set. You're going to find that you're going to have 2 numbers in the middle. You're going to have to add them up and divide by 2. So go ahead and find the median of these prices right here. $5, $9, $11, $12, and $19. Should be pretty easy. What is the middle number? All right, I'm hoping you're saying 11. Okay, here's how I figure. The median is the middle number. All right, my numbers are already listed from lowest to highest, right? I start at 5, I go to 19. It's going in ascending order. So if I get rid of the 5, I get rid of the 19, I'm left with 9, 11, 12. I get rid of my next highest and lowest, that's 9 and 12. I'm left with 11 in the middle. So right here, the median is 11. You're just getting rid of the highest and lowest until you arrive at the middle number. And the reason why this is so easy is because there's 5 numbers, which means there's only 1 number in the middle. All right, find the median then of these prices. We got $15, $19, $21, $22, $31, and $39. All right, well, hopefully you got something like $21.50. And here's how I figure. Finding the median, we got to get rid of the highest and lowest until we arrive at a middle number, all right? So I'm getting rid of the 15 in my head, crossing off 39 in my head. I'm left with 19 through 31 left over. I cross off the 19 and the 31, and now I have two numbers in the middle. And what do we do when we have two numbers in the middle? We add them up and divide by 2. So, getting out here, here's 21 plus 22, add them up, 43, divide by 2, 21.5. All right, so the median of this data set here is 21.5. Give this one a shot. Find the median of these prices: $55, $49, $21, $82, and $101. Difficulty here is I didn't put it in ascending order. Other than that, it's not too bad. All right, let's see. Let me just think this one through. I see the 21 is my lowest number. I'm going to get rid of that in my head. I see 101 is my biggest number. I'm going to get rid of that and eliminate that one in my head. I'm left with 49, 55, and 82. Well, I get rid of the 49 and the 82, right, as my next highest and lowest, which leaves me with 55 left over. 55 is my median. All right, feeling how this works now? This is the exact same data, except now instead of 101, there's 125. Let's see if that changes anything. I get rid of my 21, eliminate that, eliminate the 125. Now I eliminate the 101 and eliminate the 49, right? I'm left with two numbers, which is 82 and 55. 82 and 55 got two numbers in the middle. 82 plus 55 is 137. 137 divided by 2. Adding them up, divide by 2, I get 68.5. 68.5. Did I do that correctly? I'm just going to confirm in my head. Yeah.
Yes.
I think that's fine. Yep. All right. Oh, I think you know what? I'll have you do this last one here. I'll have you do this last one. Find the median of this prices. I will show this one off to you once more. All right. So I find it 68.5. Let me show you how to do this one on the calculator. Right. I press the stat button. I want to go to edit a list. So I'm going to press enter. There's data already in my calculator. I'm going to press up, clear, enter. Right. Up, clear, enter. I highlight list 1, press clear and enter to get rid of my data. I'm just going to put that data in there. 55, 49, I press enter. 21, I press enter. 82, I press enter. 101, I press enter. And 125, I press enter. All right, my data is now in list 1. I'm going to go to the calculate menu. Press that again. This time I want the calc menu. I'm going to press the right button. I've highlighted the calc menu. I want one var stats, one variable stats. Press enter. I got to now press enter like 3 times. 1, 2, 3. Okay, I want to find the median, which means I need to scroll down. There's my average. There's my mean, 72.166 repeating. But I want to find the median, which means I got to scroll down a little bit. There's my median, 68.5, exactly like we calculated, 68.5. All right, we are going to stop basically right there. I want you to find the median of these prices, and we will talk about example 4 range on Tuesday in class tomorrow. All right. Wish us a happy Tuesday and be on your way. Anyone going to wish us a happy? Oh, actually, no. Don't wish me a happy. Don't even fall for that joke. It's Monday, people. It's Monday.
Monday. Sol has the spring fever too.
But thank you, Jara. Thank you, Isaiah. Thank you, Anaya.
Anaya. Oh my God. Yeah, spring fever we got.